got another linear inequality up here on the board, 2x minus 3y less than 6. Now I know the boundary, it's going to be the line where 2x minus 3y is equal to 6. I'm going to actually solve this problem two ways because I want to show you one strategy that's an optional one. I know that it's going to be possible in this case to get the y by itself. And I kind of like having y by itself, particularly with linear inequalities, because then I know that my boundary line will be in slope-intercept form, which makes it easier to graph. But also if y is by itself, that gives me that option of saying, well, if y is less than something, it's going to be the lower part of the graph that I shade. And if y is bigger than something, it's going to be the higher part of the graph that I shade. So I'm going to try to get y by itself, but working with the inequality. So I'm going to subtract 2x from both sides. So I'll have negative 3y is less than negative 2x plus 6. Notice these are not like terms, so we can't combine them. We just have to write them as separate terms. Now to get the y by itself, I'm going to divide through by a negative 3. Now with inequalities, I want to remember that if I divide by a negative, that's going to reverse the inequality sign because that's changing the signs of everything. So if I multiply by negative 1, I'm reversing the relationship here. So y is bigger than, here these two negatives cancel, 2/3 x, and here this will simplify to minus 2. Okay. Notice in getting y by itself, the inequality sign changed. So it wouldn't be safe for me to just say, oh, my boundary line is y equals 2/3 x minus 2, and it was a less than, so I'll shade below. I need to know whether the inequality changes if I change the inequality. Now I can say my boundary is y equals 2/3 x minus 2. And notice it's a strict inequality, so that's going to be a dotted line. Okay. So my y-intercept is down here, 0, oops, let's draw this to scale, 0, negative 2. With a slope of 2/3, I'm going to come up 2 and over 3, and I'll connect those points, but with a dotted line. And then when I'm checking to see which side to shade, I don't look here because I don't have a sense of when 2x minus 3y is small. I don't know where that is on the graph, but I do have a sense of where y is big. Y is big higher up, so I'm going to have to shade above the line. So notice that if I'm using the sign of the inequality to determine which side to shade, I've got to look at the inequality that goes with y being by itself. All right, so there's my answer. Now, I'm going to do this another way because I just want to show you the option that I have. So here, I got y by itself working with the inequality. If you prefer to work with equations rather than inequalities, I could have said that my boundary line right here at this point is 2x minus 3y equals 6. Now probably still to graph that, I would choose to get y by itself. So I would subtract over the x's. So we get negative 3y is equal to negative 2x plus 6. Divide through by a negative 3, y equals 2/3 x minus 2. Okay. So I get the same boundary line, and of course it's dotted because we've got a strict inequality, so I could graph that. But if I switched from an inequality to an equal sign before I got y by itself, now I can't use the inequality to determine which side to shade. Here's a time where I would have to just pick a test point. So I'm going to pick as my test point the origin, which would be 0, 0. That's this point here. It's clearly on the upper left side of the line. So then we just ask ourselves a true-false question. If I plug in 0 for x and 0 for y, is that true? This would simplify to 0. So it becomes, is 0 less than 6? And the answer is yes, that is true. 0 is less than 6. So the origin should be on the side that I'm going to shade. Okay. So I get the same graph either way. I just wanted to show you both options. I prefer to get y by itself working with the inequality. I think that's simpler just because I'm not crazy about picking a test point. I prefer to just look at the sign of the inequality when y is by itself, but that really is a matter of personal preference. What I'm going to do is put a linear inequality on the board for you folks to try. What I'd like you to do is before the next video, try graphing this, and then we'll go through it together in the next video. So let's try 1/2 x plus 4y is greater than 8. Okay. And this does have a fraction in it right there. We can deal with that. You've got a couple of options for dealing with that. One is you can just keep it as a fraction. Another option would be if you wanted to clear the fractions, you could just multiply through by 2 to eliminate that fraction. Although if you get y by itself, you might very well be introducing a fraction again later on in the problem. So I'll leave it up to you to figure out how you want to deal with that. But try to work that out and graph that, and then we'll go over it together in the next video.